Hello, Advanced Algebra. This is Mrs. Slater. Pat wanted me to give a shout out and a little riddle. Why was 6 afraid of 7? All right, today we're doing 1.8 notes, properties of exponents. So there's going to be two basic concepts that you're going to have to know, how to multiply and then how to divide. First with multiplication. Notice that A is the exactly the same base. So you can only do these rules when you have the same base. Okay, and we'll do some examples also. Okay, and when you do have the same base, you can add the exponents together. So it's going to look like this. A to the m plus n. Okay, so let's look at some examples with that. And I first want to start out with some pretty basic things like, so this will be number 1, x to the third times x to the fourth. So since they have the same base, we can add those exponents together for an answer of x to the 7th. Okay, you can also do this with numbers like 4 and 4 to the third. What this tells you is that if they have the same base, I can make that into one base and then add the exponent. 1 being invisible and the 3, which is there already, to give you 4 to the fourth. And sometimes using these properties is going to make it easier to simplify your final answer. So I'll let you find out what that is. So go ahead and push pause and get your calculator. Okay, the third example, you could have more than one variable. So let's say you have a times a to the 5th times a to the 6th. All of those together is 1 plus 5 plus 6. So we'll have to leave our answer as a to the 12th. Okay, now, when you're dealing with parentheses, you're going to see examples like this. We have 2y to the 5th and 3y squared. Okay, on this type of problem, you're going to notice that there are y's that are common. The 2 and 3 are separate from them. So I'm going to go ahead and take those apart. Get rid of that. Okay, so then you have 2 times 3, and then the y to the 5th and the y to the 2nd will be together as well. Okay, this makes 6, 2 times 3, so we just do those like a regular multiplication problem, and then you're going to add the exponents. So 5 plus 2 is 7. Okay, the next one, so push pause, go ahead and write that down, and then when you multiply this together, very similar to the last one, you can take the negative 8 and the negative 9 and put those together, and then also the a squared and a to the 4th. By separating them, it'll make it easier to figure out, okay, what do I need to do with the exponents? This is a normal multiply integers together. 2 negatives make a positive, and 9 times 8 is 72. And then this, same base, means I can add the exponents. So I can get 72a to the 6th. Okay, so let's do just a couple more on multiplying and dividing. This first one, it mixes in what we did yesterday with 1.7. So 4a squared, 2a, close parentheses, to the third power, and then negative 3a to the 4th. Okay, so we have 3 different things, and what makes this tricky is because we have this right here in the middle, where it's 3 that is attached to both of them. So I'm going to go ahead and write this out, no changes here, and I'm going to write this out with no changes either. Okay, and then this one, as we know, this 3 is attached to both of them. So we have 2 to the third, which is 8, and a to the third. So now we have 3 separate, and everything on the outside, any exponents on the outside of the parentheses, I have already fixed. Now I can get down to what we were just doing on the last 5 examples. So we know that that equals 4 times 8 times negative 3. And then all the a's together, a squared, a cubed, a to the 4th. And then for your final answer, 32 times negative 3 is negative 96. And then when you add all the exponents together, you get a total of 9, it looks like. So 2 plus 3 is 5 plus 4. All right, so that's your final answer. And then number 7, I'm going to give you another one, and this time I want you to press pause and try it yourself It's a mix of a lot of the things from yesterday and today. Okay, so go ahead and push pause and then we'll put the answer up. Okay, so hopefully you fix this first, because like I said before, you've got a 2 on the outside, so we need to look at it this way. Negative 2 squared and b squared. This will make 4, and then that b squared will come down. Another 3 on the outside, so we've got to fix that first. Negative 5 to the third power is negative 125b to the 6th. Now, a little side note to this. We'll talk more about this tomorrow too for part B, but just a little side note. When you have a power to a power, you're going to multiply the exponents. Multiply exponents. Okay? Alright, so we'll talk more about that in the next lesson. And then we've got a negative b all by itself here. Alright, so if we're going to put this together, it would be 4 times negative 125 times the negative 1. I'm taking that negative from right here. Okay? And then the b's I'm going to put together as well. B squared, b to the 6th, and b. I did not take that negative because I used it over here. Okay, so if you put all of that together, okay, you should have ended up with positive 500b to the, there's an invisible one right there, 789, so b to the 9. That would be your final answer. Okay, so let's go ahead and do divide and simplify. The main rule you have to remember is when, again, you have the same base. Notice they are both a's. This is the only time that you can use this rule is when you have the same base. Okay, so if that happens, it'd be a and then m minus n. You always subtract the top exponent by the bottom exponent. Some examples that I want to show you when you have to divide and simplify will look like this. A to the 4th, b to the 6th, all over a squared b cubed. Okay, so individually, we look at the same base right here. So a and 4 minus 2, and then the other one is the b's. So you have b and then 6 minus 3. Okay, so your final answer would be a to the 2nd, because I'm just evaluating the exponent, and b to the 3rd, because I'm evaluating that exponent. Sorry, my b's and 6's look a lot alike. Okay, so let's go on to the next one. I think that was number 8, so then this would be number 9. Okay, and in number 9, the problem I want to do is negative 9 x to the 6th, y to the 9th. Oops, okay, and then 3 x y to the 4th. Okay, so let's group the ones with the same base together. Here are the x's. And here are the y's, and then there's just some regular old numbers right here, so you can just do those by themselves. Okay, so the first part, negative 9 divided by 3 is negative 3. No exponent rules need to be used for integers. Okay, and then this one, we have x and then 6 minus the invisible 1. And then the last one, we have y and then 9 minus 4. Okay, so if we clean that up, it's going to look something like this. Negative 3, x to the 5th, y to the 5th. And that would be your final answer. Okay, push pause and write the next one down. Now that you have that written down, let's go ahead and simplify. And again, looking at the 3 groups we have, there are some integers without exponents, so they are separate. You have a's, those have the same base, and b's with the same base. Okay, so beginning with the integers. Negative 5 divided by negative 10, well, we know negative divided by negative is a positive, and then 5 over 10 reduces to 1/2. So I'm going to go ahead and get my fraction bar set up. Okay, and then the next one, green, we have is a to the 6 minus 2. So that's going to be a to the 4th. And all of your answers, when you subtract them, all your answers will be in the numerator. Okay, so then when you do the blue one, this may throw you off a little bit, but it's 5 minus 7, which we know is negative 2. Okay, so b to the negative 2 will live right here. All answers when you subtract are going to be in the numerator. Now, let's say, for example, you cannot have negative exponents. Negative exponents. Okay, so if you cannot have negative exponents, what effect is that going to have? Well, your a to the 4th is fine because it's positive already. The 2 is fine because there's no exponent on there. And then, I guess there's a 1, but it's not a negative. And then the b squared would be in the bottom. Okay, so that would be your final answer if the question did say no negative exponents. Okay, so let's just do a couple more. Number 11, I want you to go ahead and push pause and see if you can solve this one. 2x to the 4th, y to the 5th, over 2xy to the 3rd. So it mixes in what we were doing yesterday as well. Okay, good. Push pause, see how you do. Okay, now that you're back, the top, you can leave the same so we can clean up what's going on in the bottom. So we know from the exponential rotation that 3 is going to go on to every single one of these numbers right here. So 2 to the 3rd is 8, and then you have x to the 3rd and y to the 3rd. All right, let's group them again. Integers, that's going to reduce to 1/4. X's, 4 minus 3 is x to the 1st power. And then for the last, y and 5 minus 3, that's y squared. Now to make it look a little cleaner, we don't have to put the 1 in the front because it's multiplied by something else. We don't have to put the 1 as an exponent. And then that would be the cleaned up version. Alright, so let's do that again. But and what I mean by again is we're going to actually do another one. I want you to push pause and let's see how you do. So we have 28 x to the 7th y over 35 x to the 9th y to the 5th. Go ahead and push pause now and solve. Okay, so let's see how you did. The first one, those are just integers, so you're going to reduce those. And 7 goes into both of them, so it's going to leave you with 4/5. The next one, you're going to subtract those, so it's x to the 7 minus 9. So you get x to the negative 2. Again, reminder, you should have that in the numerator when you subtract. And then the last one, the y's, would be y equals 1, invisible 1 right there, minus 5. So you have y to the negative 4th. Okay, so if we have no negative exponents, let's go ahead and just practice that as well. The x squared would be in the bottom, and the y to the 4th would also be in the bottom. And that concludes our lesson for today. And if you haven't heard the classic why was 6 afraid of 7? Now you know that it's because 7, 8, 9.